We're going to be solving equations with variables on both sides. What it means by having a variable on both sides is that we have an x on the left-hand side, and in this case, we have two x's on the right-hand side. So whenever we have variables on both sides, our first step is always to simplify. Can we simplify the equation? The left-hand side is already simplified, but if we look at the right, we see a 2x and a negative x, and that gives us 1x. Now, in order to get the x's on one side, we're going to do the opposite operation. I always like the one that's the least, and so I'm going to subtract the x. That gives me 4x minus 3 equals 6. This is now a two-step equation where I add the opposite, and then I'm going to divide by 4 in order to isolate the variable. And that gives me my answer 9/4. So if we look at example 1, letter A, I have x's on both sides. So I'm going to subtract an x. And that right there gives me 2x minus 5 equals negative 7. I have my two-step equation. So the first step is adding the opposite. So I add 5. That becomes 0, and I get 2x is equal to negative 2. I divide it by 2, and my answer is x is equal to negative 1. Now, if we're looking at letter B, notice that we have to first add the like terms. We have our equal sign that kind of divides the equation in half. We see that on the left-hand side, we have two terms that are the same. So that right there is going to be 7x. I bring down the 4, and then the 9x plus 11. I'm going to bring the smaller x to the larger. It technically doesn't matter which x you bring to which. So in this case, they cancel. So now I only have x's on the right-hand side. And what I'm going to do is I am going to subtract the 11. And that gives me negative 15 is equal to 2x. So in order to get the x by itself, I'm going to divide each side by 2. And that right there gives me x is equal to negative 15 over 2. We could leave it as an improper fraction. There's nothing wrong with that answer. Now, as you look on, the problems get a little bit more difficult. So in this case, we have two different things that we're going to be doing. First, we're going to take our parentheses. The number outside the parentheses, we're going to distribute to each term inside. So we get 4x minus 28 minus 7. Then we're going to distribute the 9 to each of the terms, and that gives us 9 minus 81x. I'm going to combine the like terms, so that gives me negative 3x minus 28 is equal to 9 minus 81. What I'm going to do is I'm going to add the 81 on both sides. I like my x to be positive. That cancels. Now we have x's just on the left-hand side. So I have 78x minus 28 is equal to 9. I'm going to add the opposite. So I add 28. And when I do that, I get 78x is equal to 37. I divide by 78 in order to isolate the variable. And that gives me an answer of x is equal to 37 over 78. Now, looking at letter D, once again, just like the last one, we see parentheses. Parentheses tell us we need to distribute to each of the terms inside the parentheses. So this becomes 3x minus 18. I'm going to distribute the negative 5 to each of the terms. Negative 5x minus 10 is equal to 5 minus x plus 3. Once again, I'm looking for like terms. So I see the 3x and the negative 5x, and that gives me negative 2x. Then I see the negative 18 and the negative 10, which is negative 28. And I also see on the right-hand side the 5 and the 3, which gives me 8 minus x. I'm going to add 2x on both sides. I just like my x to be positive. The x's cancel. I get negative 28 equals 8 plus x. I'm going to subtract the 8, and I get x is equal to negative 36.